The recording. I'm glad I remembered to do that. Okay. So anyway, my name is Jason Vandiver, building program manager for Spear. I'm assuming most, if not all of you on the webinar this morning know Spear. Just keep in mind, I recently got some funding from DOE to provide 2021 energy code training. So if your jurisdiction or your builders would like that, I'm happy to travel and provide that in person. I'll actually even bring everybody a code book. I have, about 300 2021 IECC code books with commentary. I'm a big fan of the commentary personally. And I'm keep in mind, commentary is not code, but it does help you kind of learn where it comes from and the thought process behind it. The new premium code versions on ICC's website also will, the code change proposals, you can click on the little icon and it will give you some background on the code change proposal as well. But speaking of background on code change proposals, I'm sure Christopher knows lots of these and how they got into the code and why they're important. Christopher, the floor is yours, good sir. If you'll just let folks know who you are, and I'll let you introduce yourself, and the floor is yours.
All right, very good. Thank you, Jason. Good morning, everybody. Before I proceed, Jason, you can see my screen now, right? The first slide?
Yes.
Okay, excellent. Yes, my name is Christopher Dunn. I'm the Vice President and lead the Controls Department at Lighting Associates, lighting representative agent in Houston, Texas. LAI has been in business for 50 plus years. I've been in the professional lighting business, first having started in the theatrical realm and then moved over to commercial lighting 20 some odd years ago, after spending some years working in professional theater and then teaching at the High School for Performing and Visual Arts in Houston. So I have that educator's sensibility. So when Jason and I first connected, we were just talking about this 5 years ago. I like the idea of sharing information that is beneficial to everybody who works in this realm, which touches on what I was just saying to Jason a moment ago. I'm a firm believer in getting this information to you as efficiently and as accurately as possible, because I think the work that you guys are about is vitally important to the municipalities. The quick background for all of this history lesson is there's something called in California called Title 24, which began in 1968. And Title 24 was an approach, and it still is in existence today. And they have been looking at building codes and energy efficiencies for plumbing and HVAC and lighting controls since then, with the sole objective of how can we squeeze more out of less energy consumption. With the advent of LED lighting in the last 10 plus years, that created a dramatic shift that allowed the technology to take advantage of what LED lighting had to offer, first from an energy consumption standpoint and then from a control management standpoint. So a lot of these things that you see, not a lot, but all of these things that we're going to see in IECC Code 2021, just like it was in 2015, 5 years ago when we were looking at it then, all came out of what California learned and experienced first. Very simple illustration of that is years ago in Texas, because we learned this from California, we introduced occupancy sensors. Put a sensor in the room, somebody steps in, the lights come on and they leave, and that sensor will shut the lights off 30 minutes later, or shorter if somebody wanted it to be a 15-minute timeout. Well, they learned in California that they were still wasting a lot of energy. So because if you're like me, you could leave your office and forget something and run back in to pick up something off of your desk. You stepped into the room for 15 seconds, but that sensor is going to turn the lights on and leave them on for another 30 minutes while I've just run in and run right back out the door. So they came up with the term and the concept of vacancy sensing, which means human must turn the lights on, manual on, sensor will shut it off when it becomes vacant. That's just a simple illustration of the changes. Now they have augmented that vacancy sensing, but that's kind of a very simple illustration of where these things came from. It's not, as I've had to explain to other companies across the country, this is not some device that was developed by manufacturers to try to make more money for themselves. It's really been about trying to meet the demands because as a nation, our demands for energy are not diminishing, they're only increasing. So in the city of Houston, where I'm based, we are still 2015 IECC. From talking to Jason a few months back, he made it known to me that it's that the probability is certainly very, very high that the state will go to IECC 2021, just like it did statewide a number of years ago when it went to IECC 2015. So here we are with a presentation on this. So you'll see similarities if you've been operating in IECC 2015 and 2018, but 2021 is a step further. So some of this may be review for you. Some of you may be new to being inspector, and this may all be new information. Either way, having been a former teacher, I welcome your questions. Jason and I were just talking about how to navigate that. So I beg your pardon, he'll be monitoring that for us and can interject as he sees fit. So with that said, let's get into the first slide. So quickly, our objectives, what's in the new code and who's affected by it, and then how does this apply to this particular bent and lighting control system design, and what parts are required for code compliance. Simple enough. So quick review. This is a simple snapshot of what a basic networked lighting control system looks like. Jason, is my
yes, we can see your cursor.
Okay.
And look, 1 second of housekeeping, and then I'll turn it right back over to you. Chris was nice enough with the course evaluation. Everyone will get a PDF copy of his slides. So don't worry about, you don't have to take good notes or anything. You will get a PDF copy of the slides with the course evaluation. And then also I'll probably get this webinar scheduled either today or tomorrow and send out an invitation. On the 24th of this month, we're going to show you how in ComCheck actually captures these things that Christopher is going to tell you about today. However, if the architect and engineer don't properly fill out the ComCheck notes correctly, you have no chance as a plans examiner of tracking all this stuff down. I mean, you certainly can't spend 100 hours on a set of plans. And so we're going to get in the weeds on how you need to transfer this information to the ComCheck, how you need to require the architects and engineers to fill out the ComCheck such that everything Christopher's talking about today is easily verifiable during the plan review process. And yes, I will hold, just type your questions in the Q&A or in the chat and we'll get those at the end. Back to you, sir.
Okay, very good. So this is a simple illustration of what a basic network system looks like. You've got a central processor that will be located someplace in an electric room. And depending on the size of the project, you might have 2, 3, 4, 5 of these. What you have over here is a control and power run for your relays and dimming relays. which is pretty much required dimming, in almost every scenario these days. Not absolute, but it is used considerably. Your control devices. Here, what we're talking about are your ceiling sensors, your wall sensors, your switches, anything that's going to communicate to the lighting system within a given room to turn the lights on and off as code requires. And then if someone wishes in a network system, they can put it on their own local area network. So you might see this in large office building applications, a big firm, say a Chevron, a McDermott, a hospital system, or even schools, public high schools as well as universities. This is not a code requirement. It's just something that is often done. This is not a code requirement, but it's the easiest way to do time clock for a lot of lighting control systems out there. Not all of them, but if they need time clock control, which many of these code requirements now require, it's the easiest way for many companies to do this. And this is showing a central location box. We call this centralized lighting control. There's a relay cabinet, and again, depending upon the size of the project, a number of relay cabinets with the requisite number of relays and dimming relays to accommodate the number of rooms within a space. So the industry has actually moved away from this more and more, and they've gone to a decentralized approach. So you're looking at a cabinet here that could hold 16 or 24 or 32 relays, dimming relays in it. And that would be for not necessarily 32 different rooms. It could be for 28 rooms, and three other rooms have 3 lighting zones in them, and they want to be controlled independent. When you want to control a light independent of others, you need a new relay. So it's actually gone the route of decentralized, meaning that they're going to put in within a given room. And we'll look at some of these drawings in a second, and this will make a little more sense to you, but you will see the one lighting load relay or the 2 or the 3 that are within a given space to do the very thing that this item is doing here.
Okay, those relays typically last. What's the? Are you replacing those fairly often, or that once you install this, what's the longevity you typically get?
20 years is not. 15 to 20 years is not uncommon. We've seen changes made about every 10 to 12. But yeah, these devices that are intended to last a good long while. And the only thing that would bring about a change would be maybe there was some electrical event that damaged a relay. But all in all, these things are designed to last a very long time. Well, I didn't know those would carry through, so let me see if I can get rid of those real quick.
Get your eraser out.
Well,
yeah, I have no idea.
Yeah, I got to figure out how to do it.
You've already eclipsed any sort of technical expertise I have by just making them right in the first place. I never even get that complicated. Oh, there you go. Look at
okay,
that.
good. Let's hear it for undo. Yeah. Okay.
That's great.
So I think, okay. So there we are. So these are the types of sensors that I was talking about. Over here on the left, this would be an exterior sensor, could also be a high bay sensor, something above 12 feet. Your ceiling sensors over here, most of the ones out on the market are good for a 9 to 12 foot ceiling. When you start getting beyond that, some sensor manufacturers have to move toward something like this. And now you've got a range that will take you up to 40, 45 feet. And here is a wall sensor that is the same principle as this. And you've got a keypad with buttons. These are low voltage connections to a relay, which, as I said, can be in a large relay cabinet in an electrical room for the entire floor, or something that's about the size of a 4-inch J box within the same room. Timer switches, we do have time switch control, and this is a line voltage sensor switch, occupancy sensor switch. So a lot of small offices, even with IECC 2021, this can meet code. Networking is not required in many of these spaces. So this is a simple, cost-effective approach to meet code. It can be set up as a vacancy sensor. Someone comes into their office, they turn the lights on, and these sensors here will be looking at the room entirely. And when the space becomes vacant, it will shut the lights off. IECC 15, it was 30 minutes, and IECC 2021, it's now 20 minutes. So all four of these are detection devices looking for human presence. And in the absence of human presence, their function is to communicate to the relay within the room that's controlling the lights and turn that off. Keypad is simply there to allow a person to turn the lights on, as well as dim the lights. If they have multiple lighting levels they want to achieve, or different lighting zones they want to turn on, they can do that. And
Christopher, what's a ball? Sorry to interrupt. What a ball on the non-network, the second one from the right? Yeah, the ballpark price for a simple vacancy sensor. Just
something like that. To the cost of a contractor is going to be roughly around $100 to $125.
Oh wow, okay. And then Namisha raised your hand. If you'll just type your question in the chat or the Q&A. Back to you, Christopher.
Okay. Areas requiring occupancy sensors, and you will see this in the code. They will call all these sensors occupancy sensors, and then they will further define which rooms are working on vacancy sensing. And I'll reiterate what that is again when we get to it. So this is, they've expanded this list a little bit in 2021. The classrooms, training rooms, these were all there before: lounges, enclosed offices. Open plan office areas is something new over 2015. Open plan office areas that are larger than 300 square feet, I should say. Previously, it was allowable to not put a sensor in such a space and use time clock control and just put a switch on the wall that anybody within that space could reach. That is no longer the case. Sensors are required even in large open office work areas. Restrooms, storage rooms, locker rooms, these have all been there. Exempt areas, designated security or emergency required to be continuously lighted. So that's we're talking about the first three items really are all about emergency egress. What hospitals require is a little bit different than some commercial spaces. And like what Jason was saying earlier, ComCheck is a really good tool to check the engineer's work, that they are getting the proper amount of security or emergency lighting required. And the whole point is, in the need of an emergency evacuation, we don't want lighting controls to interfere with anything with the lighting. So there are those tests where, in the case of some commercial buildings or school classrooms, excuse me, where there might be a designated light fixture that's getting fed with normal power and emergency power, and there is a device that requires a UL 924 certification to allow that fixture, excuse me, the device bypasses all lighting controls. If the fixture's off and the emergency power kicks in, that 924 device is going to take that light to full on. Or if there is a sensor in the room and it has it dimmed down, or if the light's in any other state, the 924 device, because it's getting power from an emergency lighting source, which could be an inverter or a generator, it's going to turn the light to 100%. I've underlined the 20 minutes here. Jason, let me ask you a question. Is everybody seeing the black at the top where it says, start video, participants chat? Because it's blocking. Okay.
No, I'm just seeing the C405 across the top.
Okay. Yeah, because it's on my side, and I wanted to be sure people could read what that says there. So now they're talking about occupancy in non-warehouse and non-open office areas. So automatic shut off after 20 minutes. That is a code change. It used to be 30 and now it's 20. Some of you may have been working in municipalities for IECC 2018, and it was 20 minutes with that. Houston, like I said, is still on IECC 2015, as are other regions of state of Texas and Oklahoma. And it's now going to be going to 20 minutes. Now, the next one is they must provide a manual off to allow occupants to turn lights off, or controlled to automatically turn on lighting to not more than 50% power. Okay, so you can have a system where the lights are being governed by some kind of timer and a processor, but I've yet to find an engineer who wants to lay out a space where they don't put a light switch on the wall. People like to have that tactile experience, but there is a way of getting around it, but it's got to be no more than 50% power. Otherwise, you're in a room, you're looking for the sensor on the ceiling and see that the timeout is in 20 minutes and that there's a switch on the wall. And we'll delve a little bit deeper into where its occupancy is allowed and vacancy is allowed. That's coming up. Exempt spaces, full automatic on with no manual control is permitted in. And all of these make good sense. Corridors, interior parking areas, stairways, restrooms, locker rooms, lobbies, essentially where the public could be visiting a building and it's not incumbent upon them to find the light switch to turn the lights on in a corridor. It's really 100% okay that the sensor is there just to catch them and turn the lights on, or in a stairway, et cetera. So simple logic. So we jump to the lighting in the warehouses. They must reduce lighting power by at least 15%, 50, when unoccupied, again, within 20 minutes. Another change from 30. They can go more than 50%, but they can't just go down 25 or 30 or 45%. It's got to be at least 50. This is nothing new, but it does, oh, I didn't realize that would happen. This is one that some engineers I've seen will sometimes forget, that aisleways in a warehouse have to be controlled independent of one another. So if there's a large warehouse and they've got 20 aisles, minimally, you need to see, I would say, 40 sensors, one at each end of the aisle. So 2 times 20 is 40, because those different lighting zones have to work independent of each other. And if they've got 20 aisles, there needs to be 20 relays of some sort. They could be in a centralized panel or they can be distributed, because a relay is only supposed to affect whatever lights are connected to it. So you can't put, though you could mathematically on the power side, put 3 or 4 or 5, depending on the size of the aisle, on a single relay. But if that sensor is not detecting anybody in in aisle 2, it could potentially turn the lights off on all 5 rows. Can't have that. So there will be independent relays to go along with this. And we'll see this again in another open office application. Lights not turned off by the sensor shall be turned off by a timer switch, complying with section 405.2.2.1, which we will touch on. Another way, it's just saying if they chosen not to use a sensor to shut lights off, they can get by, meet code by having a timer switch there within the vicinity, and we'll see more of that right there. And there will be a time allowable for that. And manual control shall be provided to allow occupants to turn off lights. Again, that's just basic human behavior, and it needs to be there. Okay, now this is for functionality in open plan offices greater than 300 square feet. This is something new. It first appeared in IECC 2018, and it's being shown again in IECC 2021. Motion controls are limited to a 600 square foot footprint. So let's talk about this. You got a 2,400 square foot space. I'd rather double this one here. And we'll look at this again, some examples. You need a minimum of 4 sensors, 4 ceiling sensors that you see here to control each 600 foot space. And this sensor here cannot be controlling the lights over here and vice versa. There's also a daylight sensor that you see here. This is something new from 2018. It's carried over into 2021. So 4 more in that 2,400 square foot open office space. You now have a minimum of 4 independent sensors working with 4 independent relays, dimming relays, for lighting control. Plus you need to have switches in the room, and you also have the options for an automatic on is permitted in each control zone. Other unoccupied zones are permitted, but not required to come on to 20%. Okay, so what does this language really mean? You do not have to have manual on for an open office space. You can have the sensor turn the lights on, but it can only turn the lights on in the 600 square foot space. So I walk into this space and there's nobody over here. These lights are still dark and these lights will come on. That's fine, that's acceptable to code. I walk over into here and I'm the only one here. These lights will come on and these lights will go off in 20 minutes or less. Or I come into this the sensor turns the lights on automatically for me. And this sensor turns the lights on to no more than 20%. It can be one or the other. But you can't walk into this space and have this space go full on. That would be a code violation. Or not even full on. It can't go to 30% or 50%. It's either this is full on and this is off, or this is full on and this is no brighter than 20%. That's what this is saying here. No surprise, control shall automatically turn off general lighting in all zones within 20 minutes. So whether it's one space or all four spaces become vacant, they need to go dark within 20 minutes. Okay, and the general lighting in these zones shall turn off or reduce to not more than 20% within 20 minutes. So these three are linked together as I was just describing. It can be full on, this stays off, or full on and this goes to 20%. You vacate and they should go off. Okay, occupant sensor control functions to corridors. This is a slight change. Occupant sensor controls in corridors shall, here's an important word here, uniformly reduce lighting power to not more than 50% of full power within 20 minutes of vacancy. What they mean by that term uniformly is, let's say you've got a really long corridor and you've got a series of either 2x2 troughers or 2x4 troughers, and it's a long corridor. There's 12 of them in there. You can't have the 2 on the end and 2 on this end shut off and everything else in the middle stay at full on. That's not uniform. They need to be reduced, and they put it this way because the technology, frankly, with lighting controls and LEDs allows it to do so. So, but there will be those who will want to skirt this term, and your role is just to make sure that they don't. I don't know if you guys ever get photometric information on projects before you go to them, or if you actually go in with a light meter, but they did add this. This is an interesting exception. Corridors provided with less than 2 foot candles of illumination on the floor at the darkest point with all lights on. So what that's saying is, if there's a large corridor and they spaced out the lighting and it's less than 2 foot candles of illumination at the floor, then this is no longer required. Don't see that very much from what I've seen on engineered plans, but it is an option. Somebody can have a little bit less light in their corridor, but still enough to meet code for emergency evacuation. And as long as they're inside of 2 foot candles at the floor, they do not have to follow this. Okay, areas not controlled by an occupant sensors require a time switch control. That's pretty straightforward. Sorry about that. I'm a guest in someone else's office.
Larry needs to get line 2.
Yes. So there is an exception for specific application controls, which we will touch on here a little bit later. Exceptions also are where there's any direct patient care. For understandable reasons, the medical community gets a lot of latitude with lighting controls that other businesses, industries, enterprises do not. Makes sense. You're seeing a physician, you do not want the lights shutting off on you, or even dimming down 50% in the middle of any kind of examination.
Or surgery, that'd be bad.
Yeah, yeah, that would not be so. Yeah,
well, that's
not
what.
too many sensors. Yeah, if that surgeon's pretty still and not making a lot of noise,
right?
you don't want the lights going on.
But on the residential side, I don't know if you noticed in the 2021, in the bedroom, you now need occupancy sensor controls or dimmers. I can't imagine what might go wrong with occupancy sensor controls in the bedroom. I don't know, but it's made its way into the residential as well.
Yeah, it's a carryover from hotel dwellings, which we'll touch on later. Well, I didn't know
yeah,
that
they got a lot pickier about hotels, and I know you won't cover mechanical, but the mechanical setbacks are a lot stricter. They really
is that right?
Yeah, yeah, it's a little much for really hot or really cold climates in my mind, but it'll save energy.
Okay. Areas where automatic shut off would endanger occupant safety or security. The best example of that is any kind of manufacturing or assembly floor. Someone's working with even simple power tools. It's not difficult for them to make the argument. No, we turn our lights on and we leave them on all day while people are working, and then we will turn them off because you cannot afford to have somebody who's working on some light or working on building something, have the light shut off on them, just like Jason was saying, in an operating room. Lighting intended for continuous operation, like an operating room. And shops and laboratories. Shops can be retail shops, and labs, again, is anything that, again, there's some common sense here. A lab where they're either engaging with chemicals or fire or anything that could put a person physically at risk. There's no reason to have automatic time switch control and put somebody in harm's way. Time switch functionality. So where you do have time switch control, this is the criteria that needs to be met. It's supposed to automatically turn off the lights when the space is scheduled to be unoccupied. Okay, that makes sense. If it's supposed to shut off at 5 p.m. or 6 p.m. or 7 p.m., need to see that happen. The time switch device itself must have built within it the capability of having a minimum of a 7-day clock and capable of 7 different day types. That's usually Sunday through Saturday, have a holiday shutoff schedule capability, and program backup of at least 10 hours. So what they're essentially doing is they're making sure that commercial grade timer switches are being utilized and not something somebody just picked up at Home Depot, like you would for a residential space. So that time switch needs to have this capability. Do you need to necessarily see it perform all of those things? No, maybe they should just show you the data sheet on what is being used in that space. It does need to include an override switch, and there is a maximum of a 2-hour override. So they can't hit the override and have the lights stay on indefinitely or 3 hours. It's got to be for no more than 2 hours. And that override switch cannot govern more than 5,000 square feet. In those spaces where you have really large areas of square footage like mall concourses, auditoriums, manufacturing and sports arenas. The override is okay if it's controlled by a key switch for greater than 2 hours. And that space is greater than 5,000 square feet and less than 20,000 square feet. Because again, it would be too impractical anyway to try to subdivide a mall concourse into a series of 5,000 square foot areas. Okay, now we're going to occupancy and uniformity and vacancy. Manual controls to allow occupants to reduce lighting by at least 50% in reasonable uniform pattern. The most common way is this way that you see here. All the lights are dimming. The most common approach to light fixture dimming on the commercial market is the analog approach, which is 0 to 10 volt. 10 volts is lights are at 100% and 0% is actually, it's not off. It's just reduced to the capability of the driver. And let me mention something here on the 0 to 10 volt dimming. I keep doing that, I apologize. 0 to 10 volt dimming, the dimming itself with LED light fixtures and fluorescent fixtures is done by the LED driver or the fluorescent ballast. The lighting controls is just sending a 0 to 10 volt pulse to the LED driver that's in this fixture and this fixture and this fixture and this fixture and this and so on and so forth. So what's doing the dimming is built into these fixtures. The lighting controls coming from that dimming relay that's in the room is just sending, take these to 8 or take these to 6. And the LED driver can take that light down to 10%, which is actually still 32% of visible light. It's not off. If you want off, you got to hit the off button. 1% is 12% of visible light, and there are some LED drivers that do 0.1%, which is perceived dark, but it's still not completely off. And that's just a function of a LED diode working off of a driver. Has nothing to do with the lighting control manufacturers. They're just sending that 0 to 10 volt pulse. You may see this in these other options, alternating fixtures. This is called uniform, or if you're all fluorescents, you're controlling all of the fluorescents in a uniform pattern. If any of you are running into this, I would be really, really surprised. Fluorescents are going the way of the dodo bird. They're just, they have no real life, long life ahead of them. So exceptions to the lighting reduction controls, spaces that only have one light fixture in it that is pulling less than 100 watts. And you may see that in some small offices, not that many, but you might, or spaces with the lighting power density of less than 0.6 watts per square foot.
You'll see that more, quite a bit more,
Yes.
right? Yeah.
Yes. Yeah. Because LEDs do not draw a lot of power, and my office has two 2x2 fixtures in it. So I'm less than 100 watts with both of those, but I have 2 luminaires, but I am still within the 0.6. But I do have a line voltage sensor switch nonetheless. And as we showed earlier, corridors, lobbies, they do not have to have the automatic lighting reduction. Electrical mechanical rooms, for again, understandable reasons, some of these mechanical rooms, these guys have to walk in and around ductwork and trying to get a sensor in place that's going to see them at all times is not at all practical. So they get with a pass and they don't have to have the lighting reduction controls, because again, you don't want somebody who's working on something in a mechanical room or an electrical room and have the lights go out on them in the middle of work and put them at risk. And daylight zones are considered separate controls, so they don't fall within this. All right, so daylight responsive controls, we're going to spend a little bit of time on this. It's required in the following spaces, where you've got 150 watts of general lighting in the side lit zone, or 150 watts or greater of general lighting in the top lit zone. Okay, keywords here are 150 watts and general lighting. If there is a accent light decorative wall sconce, that doesn't go into the 150 watt calculation. They're talking about the basic illumination for that office, classroom, large open office break room. And we'll talk about how to calculate the size of the daylight zone in a second. Again, so you'll see exceptions, healthcare facilities, again, where patient care is directly provided. At no time should the lights automatically dim on a physician when he's seeing somebody, simple enough. Lighting required for specific application control. We'll visit that at 405.2.4. And side lit zones on the first floor above grade in group A2, which are spaces where they're serving food and drink, your restaurants, and group M, mercantile occupancies. So this retail stores that don't need to have their business potentially diminished because somebody's shopping and then the lights shut down on them and people can't see as well. So they don't penalize businesses this way. All right, so here we're looking at some plans that we received, and I've highlighted in yellow the daylight sensors that the engineer put on the plans. And so very quickly, this is one room. The walls come along here, and you've got two angles here, and these three sets of lights. Over here, you've got, and what you don't see is the engineer did define which lights were in the daylight zone and which were not, but they drew in two daylight sensors here. And then in these smaller offices, they dropped in a daylight sensor. And I then came back and explained to them, you don't need most of these sensors. So all of these sensors over here could be removed because the daylight zone is less than 150 watts. 87 watts here, 87, 87, 87. So they dropped in, I keep doing that, I apologize. They dropped in a daylight sensor basically because they'd rather show more than make a mistake. It's always easier to pull something out of a project than to add something. Because when you're adding, somebody's writing a check and they don't want to do that. So the owner is happy that they don't have to pay for daylight sensing if they don't want it. And the contractor is happy because it's one less thing for him to have to install. So in this scenario, two daylight sensors were removed. This one was removed because, again, I cut it off here, but this is what made up the daylight zone. And again, this is less than 150 watts. Now, the engineer drew up all of this as part of the lighting zone. And we will get to how you calculate the dimensions of the lighting zone in a moment. But one of these sensors, it doesn't matter which one, but one of these can be removed. And the reason for that is two sensors cannot control the same daylight zone at the same time. These sensors are not so perfectly precise that they are going to measure light input exactly the same way. So as well as you could have a tree over here and there's darker clouds over here, and it's going to see less light coming through. So it's going to want to ramp the lights up, whereas there's no tree over here and there's no cloud and there's a lot more sun. So this sensor is saying, hey, turn the lights up, and this sensor is turn the lights down. And so there would be this ridiculous dance of the lighting. So it's one lighting sensor per lighting zone. There's just no other way to make it work. So just because this is on the plans initially in the submittal and review process and approve all of these sensors, that these four here and this one were cut out of the project. You have two different types of photo sensors, the open loop and the closed loop. The open loop is pointed directly at the window, and it is sensing the amount of light that's coming through the window at any given time. What you don't ever want to see is a light fixture in between the window and the sensor, because then you're getting a false reading on what is really coming through the window. It's perfectly okay for this daylight sensor to be 12, 14, 18 inches from the window. I have this happened years ago, but I had a contractor who wasn't fully understanding daylight sensing, and they put a sensor 12 feet away from the window. There was like 3 different lights that were in between the sensor and the window. So of course they have to move it, because that light, this photo cell cannot properly measure the amount of light that's coming through the window. It's not supposed to be measuring, this particular sensor is not supposed to be measuring any light in the space other than what's coming through the window. The one beneath it, this one here, is called the closed loop. It's mounted on the ceiling and is looking down at a tabletop or something. So it's measuring all of the light within the space, the daylight that's coming from the window, as well as light that is within the room. And so it's making a calibration on dimming the lights within the daylight zone based on what it's measuring out for this tabletop. Easily, in what I see, 98% of daylight sensors is this type. And it's mostly due to familiarity by the engineer. But the obvious thing here, just like you don't put this one multiple feet away from a window where there can be light fixtures in between it and the window. Same thing with this. You don't put this sensor in direct line of light from a light fixture. Now I put this slide in here because the technology is continuing to advance. This sensor is what most of you, I'm sure, are seeing. And I did this as a reference point. So most of these sensors from here to here, they're 4.5 to 5 inches across. This can be an occupancy and a daylight sensor in one, or just an occupancy sensor, and you would have another sensor like this. But some that are used in warehouses, they look like this. But you know, a softball is just inside of 4 inches in diameter. And these sensors are a little bit wider than that. We now have sensors that get integrated into light fixtures. This is new technology, and it's being used by a number of different manufacturers. These particular ones from 2 different manufacturers, this sensor lens is roughly about the size of a quarter. And it's still good for up to 10 to 12 feet. It's got a 1-to-1 ratio. If it's 12 feet up, it's going to cover 12 feet in diameter. And likewise, this one gets mounted inside fixtures, and this lens actually is smaller than a dime. And in each one of these, there is daylight sensing built into it. So it's occupancy, vacancy sensing on all 3 of these, and it's daylight sensing. So you need to be aware of where is the daylight zone and if there is a daylight zone. And don't be surprised if you'll see more and more projects in the future that don't have these, and you'll see something like this. Okay, continuing on with daylight control. Spaces required to have light reduction controls have a manual control that allows the occupant to reduce the connected lighting load by not less than 50%, and a reasonably uniform illumination pattern, with an intermediate step, in addition to full on or off with continuous dimming using one of the following or another approved method. All that to say is that daylight sensor that we've been talking about needs to be able to take the lights down at least 51%. It wants the capability of providing continuous dimming from full output to less than 20% of full power. If it takes it fully off, that's okay. Switching all luminaires to a reduced output of not less than 30% or not more than 70% of full power is also okay. And switching alternate luminaires or rows, I didn't do spell check properly, that should be ROWS, of luminaires to achieve a reduced output of not less than 30%. Again, a little less likely to run into this simply because so many light fixtures out on the market are going to be 0 to 10 volt controlled. And it's very, very easy to have a daylight sensor that's working with a relay and will dim those lights independent of the rest of the general lighting. We're going to expand on this here in a second. You can have daylight sensors can be directly wired into the fixture, and that would be line voltage control, or it can be working with a relay within the room. And that's a lot more common. You might see a daylight sensor integrated into a fixture working on line voltage in parking garages or something like that. The daylight responsive controls required for areas with 150 watts or more of general lighting within top lit and primary side lit daylight zones. Hang in there, I am going to cover that. So again, why I showed you that other layout, there was less than 150 watts, so there's no need for a daylight sensor. There's no daylight zone calculation to make. Now you can find, it's getting harder and harder to do because LED lights pull such low wattage, but there might be some areas in a daylight zone where there's 300 watts or more of general lighting. And then you must create a second daylight zone. And one sensor can control 2 zones. Everybody, all the major manufacturers have that capability with their daylight sensor to effectively have a 150 watt daylight zone and then a 300 watt daylight zone. And just hang in there with me. I will explain what those look like in a moment. Healthcare and patient facilities, again, where patients can be interacting, you don't need daylight sensing. Side lit zones on the first floor above grade in A2, and we mentioned this already, your restaurants and your retail stores. And new buildings where total connected lighting power calculated is not greater than the adjusted interior lighting power alliance. And here is your reference point for that, 405.3.1, which the engineer is going to verify with ComCheck. And you'll see that mentioned in their write-up or the plans. So you won't have to make this calculation. So daylight responsive control shall control the top lit and the side lit zones separately. It's not that common that you will have both top lit and side lit lighting zones. But you will have, in the case of 300 watts or more, you will have a primary and a secondary side lit zones, and they have to be controlled separately, but one sensor can do that. They need to be calibrated from within the controlled space. So a lot of manufacturers are moving to the use of apps working off of smart devices. That would meet code there. Some still use their own handheld remotes, but it needs to be on the premises somewhere, and you need to know that it's there. Have readily accessible calibration. Again, that's a remote or an app meets that. Dim lights continuously from full light output to 15% of full output. So I don't really know why the code has this small contradiction here versus 20% in the other. I'm not on the committee, so I can't explain that. But here is the only time I've seen the 15%. But most are willing to take it to off anyway, so I don't think that's going to be an issue for many of you. And they must be configured to completely shut off all controlled lights, which again, they're connected to a relay that can be done easily. And when there are occupancy sensor controls within the same space, daylight controls shall adjust levels in response to daylight only within the zone, but shall be configured to not increase the lighting power above the specified unoccupied set point. So what that means is we have some daylight zones in a conference room, and that daylight sensor is dimming the lighting as it's supposed to be, and somebody comes into the conference room and they want all the lighting to go to 100%. Well, there's a bright day, that daylight sensor is going to be pulling those lights down from 100% through that because of the light coming through the window. And they will not be able to take those lights within the daylight zone higher than what the sensor sets them at. So they can take the lights lower if they want. They can't take the lights higher than what the daylight sensor setting is. Simple enough. A daylight sensor, you need one for each cardinal direction on a side lit, north, south, east, and west. So you can't have a sensor that's facing the north control lights in a daylight zone on the east or the west, certainly not on the south. And up to 150 watts of lighting in each space can be controlled together in zones facing different directions. And that applies to both primary and secondary zones. Okay, so here's how we make our calculation. First on the side lit zones. First order of business is you need an opening that's at least 24 square feet. So if there's one window that's 7 by 3, 5 by 4, that's just 21 and 20 square feet. Doesn't matter what the wattage of the light fixtures are in the room, a sensor, a daylight sensor, is not required. But if you have 5 2x3 windows all strung together on the wall. Now you have 30 square feet of total fenestration, and now you have a daylight zone. And so, or if it's a floor to ceiling, okay, glass wall, you have a daylight zone because you're going to have more than 24 square feet. So then how do you calculate the size of that daylight zone? All right, the easiest way is you measure from the finished floor to the top of the window. Doesn't matter where the window is. Once you've crossed the 24 square foot threshold, you just need to find the window that's at the highest point. And if that's 7 feet above the floor, if it's 8 feet, if it's the entire wall, and that's a 10-foot ceiling, you've got a 10-foot daylight zone, meaning that you now fall into the room 10 feet. And all the light fixtures that touch that daylight zone within that 7 or 8 or 10-foot line, then you have to calculate, do the light fixtures within that 7, 8, or 10-foot light zone, do they count up to 150 watts or greater? In that earlier illustration, we had 3 different lights that were all within the daylight zone in 4 of those offices, but the total wattage was only 87 watts. So no need for a daylight sensor. Can the owner have one if they want? Yes, absolutely. And then if they put one in there, then it needs to meet all this other criteria. But if it's less than 150 watts within that daylight zone, then you do not need a sensor. Some spaces, like you see over here, they have a window, wall, and then a window. The daylight zone is not just, the width is not just that of the window, it's 2 feet on each side of the window. So for sake of argument, let's say this is 5 feet and it's 9 feet tall. So our 9 feet is this line, and this is 5 feet, and we have 2, and we have 2. So we would actually have a 9-foot square daylight zone. And here's another one. This is a primary and a secondary. This falls into play if the lighting within here adds up to 300 watts. If there's less than 300 watts, but you're over 150, you don't have a secondary side lit zone. You only have a primary. So it's got to be greater than 150 and equal to 300 or more to have a secondary side lit zone. And if, like I said, if this window is 7 feet high, you're 7 feet and then another 7 feet. Hopefully that you're following me. That makes sense. Another way of looking at, sorry, it says side lit zone, and this is a top lit zone. I apologize for that mistake. But it's the calculation is based on 70% of the opening. That's what that 0.7 is, of the opening within the ceiling. So if it's a 10-foot opening, then your daylight zone is 10 times 0.7 is 7 feet. It would be 7 feet outside the opening in the ceiling. And then again, like you have here, you have a 2-foot. You also have here a 25%. So an additional, whatever 25% of 7 calculates to, that would be the full extent of your daylight zone lit from the top. Here's another illustration of it. Yeah, the floor area underneath the roof fenestration. And again, they use the word fenestration because that's a catch-all for any opening in the wall or the ceiling. They don't say window. So in the case of something like this, let's say it's side-lit, you're in a gymnasium and you've got windows that are 16 feet above the gymnasium floor. They're all along one wall and you're well over the 24 square feet. So that daylight zone is 16 feet long, even though it might be, those are 2x3 windows. It's the floor to the height of the window once you cross the 24 square feet. The size of the window itself doesn't really matter unless there's only one window like you have over here, and then you go 2 feet beyond.
You wouldn't get, I'm just thinking of a gymnasium and a high skinny window. I mean, that seems like there should be like an area that's not lit coming right off the wall, because it's not the way that lights. Well, I don't know. I'm sorry. Go ahead.
Well, what they want is the idea, the theory behind it all is there's enough light coming through the window. It's going to just mitigate the amount of light within that daylight zone. So you're still getting a proper amount of light to play whatever game, whether it's basketball or volleyball or something else going on within the gym. And you're not reducing the light so much to a point that people can't play the particular game.
Gotcha.
Yeah. This is something that was added, and it's really just an expansion on the top-lit zone with an atrium. And the simple way to look at this is, if you've got something, here's our window opening at the top in the atrium, and we have a second and a third floor that kind of cuts into it. This is your daylight zone down here. And if there is a light fixture in here, this would need to be controlled, but your calculation for your daylight zone dimension is past the interference point. So if this line and this line came in further, this line would extend and your daylight zone would be down here. That's kind of what they're trying to illustrate here. Your daylight zone, if there happens to be some fixtures right here that need to be controlled, which is possible, but not necessarily likely, you typically aren't worrying about lighting right here and right here, but you are concerned about the lighting down in the first level. Okay, occupancy, I gotta speed this up a little bit. Occupancy sensor time switch manual control now required in display and accent areas. This is new. Lighting in display cases. This is new. These used to be in 2015. They did not have to be integrated into sensor control, as did supplemental task lighting. Task lighting has to be controlled, but it does not go into your 150 watt calculation for a daylight zone. Please make that distinction for yourselves, just like display and accent lighting. Lighting equipment for sailor and demonstration in lighting education. Notice it says education, not for retail, not mercantile. There are some lighting stores and they don't have to be forced to dim their lights. Display lighting for exhibits. Again, this could be in a lobby, a very large lobby or something, or in a museum. And here we are in sleeping units. All lighting and switched receptacles be turned off within 20 minutes of vacancy. That is new to IECC 2021. The exception to this is hotels that use key cards. That's fine. Then you don't need the sensor switching it off within 20 minutes. And again, patient care, not forcing anybody to be at risk with the physician. Permanently installed luminaires in dwelling units shall have controls using OC sensors or lighting reduction controls. This is permanently installed in dwelling units. So what they distinguish between a sleeping unit and a dwelling unit, I would say hotels, dorms. Though one can make the argument that they're both, but with hotels, you can get by with key cards where you can't in a dorm room. Specific application controls, non-visual lighting. Okay, this is lighting for plant growth, food warming, to be controlled by a time switch that is independent of the control for the other lighting in the space. Simple enough. And that can be a timer switch, or it can be something that's connected to a relay that's got a time clock control for that relay that controls the plant lighting or the food warming. This is something new. It didn't used to be part of the 15 code. Now, task lighting for medical and dental is something also that's new to be incorporated with the lighting controls, but not where physician-patient interaction is incorporated. So you go into the dentist chair, they don't have to have a sensor on the wall or on the ceiling that could dim the lights on you while he's working on your teeth. But in the spaces where a physician is not tending to you, you still need manual control for the general lighting, and all lighting and switch receptacles be turned off within 20 minutes. Okay. Manual controls must be in a location with ready access to the occupants. So simply put, if you've got a large floor and there's 4 or 5 different corridors, or you've got a string of offices, and you can't have a central bank of light switches in the electrical room to control those lights. They've got to be readily accessible to the occupants. And be located where the control lights are visible or identify the areas being controlled. Now, this is not something new, but this is something that would allow a place like Texas A&M University. They are building a new chemistry building. And the particular users of that did not want any light switches in the corridors. And the way to get around that, because that's code requirement, was, okay, we can put in additional controls that provided a touch screen that would identify the areas being controlled. You could go to the control, you could go to that touch screen and see the present status of any corridor. And this touch screen had to be accessible to the occupants. That would be the staff. Students are not necessarily the occupants. They are the quote unquote visitors. So again, they couldn't put it in an electrical closet, but they could put it in a kind of back of house corridor where students are not likely to go, but the occupants could. But it's got to be either readily accessible, which means right there in the room with the people, or some kind of way of physically and visually identifying the area that's being controlled. Exterior lighting controls, this is an expansion on this. This is nothing new. Turn lights off when sufficient daylight is available, and facade and landscape lighting to be automatically turned off from not later than 1 hour after business and not earlier than 1 hour before business opening. This is nothing new. Other exterior lighting to be reduced by not less than 50%. This too is a repeat. This is an added right here. Lighting serving outdoor parking areas with a rated wattage greater than 78 watts and mounted at 24 feet or less shall be controlled to automatically reduce the power of each luminaire by 50% when no activity has been detected for 15 minutes. So you got a pole light that's 24 feet or lower, and it's greater than, that light fixture is greater than 78 watts. There's got to be some sensor or something that's going to take that light down by at least 50% when there's nobody wandering around. And you cannot have a sensor control more than 1,500 watts of lighting together. Slight changes on parking garages to control by an occupancy sensor or time switch. That's an enhancement. Lighting power of each luminaire by a minimum of 30% when there is no activity for 20 minutes, 20 minutes being the change there. And you can't control larger than 3,600 square feet. That's also an addition in the parking garage level. Lighting for covered vehicle entrances from buildings and parking structures shall be separately controlled by a device that automatically reduces the lighting by at least 50% from sunset to sunrise. This is new. Entrances and exits used to be exempt from controls. They are no longer, but they do want them reduced by 50% in relation to activity. Power to the luminaires within 20 feet of any perimeter wall structure that has a net wall to opening ratio of at least 40%. No exterior obstructions with 20 feet shall be automatically reduced in response to daylight. It's telling you how to calculate a daylight zone. Okay. If you've got a fixture that's within 20 feet of the opening, that's at least 40%. And there's no exterior obstructions on the other side of that within 20 feet. You need a daylight sensor to take that down 50%. Most of what we're seeing now is engineers are putting this daylight sensors in there anyway, and they just tell the owner, you need this. You can always add more control. You just can't take away control. Facade and landscape lighting to be automatically turned off from not later than 1 hour after business closing. And okay, this is nothing new.
I bet you get a lot of pushback on that because, you know, people want to have their building lit up like Christmas, whether or not they're there or not, is part of just kind of advertising, and facade and landscape lighting is part of that. What do you, is there pushback? Is there exceptions? What, just elaborate on that. Just a code requirement to do it?
We had more pushback because this one has been there since IECC 2015. Yeah, there was a lot of pushback in really 2016 and 2017 in our market. And then it just was, there's no getting around this. And it became more acceptable. Rather, it was the bitter pill a building owner necessarily was forced to take, as are some of these. I mean, we still get engineers telling us, yeah, we get requests. Do I really have to have all this lighting controls? And they say, yeah, you do. You won't get certificate of occupancy without it. And we're about to touch on receptacle control, which is, I know, at least for Houston, is going to be it's going to be a hard pill to swallow for a while because they just haven't had to do it. We've had a number of projects where they did it voluntarily. Code did not require it. They wanted to do it for some lead points or just to say that they were doing it, I guess. And probably without exaggerating, I'd say 80% of the time when they called out for receptacle control, within 6 months, they were contacting the contractor who contacts us and says, how do we turn this off? Because people don't like trying to figure out which receptacles are going off when the room becomes vacant. That's what receptacle control is all about. Half of the receptacles within the room have to be shut off when the space becomes vacant after 20 minutes. So that's for private offices, conference rooms, print copy rooms, break rooms, classrooms, individual workstations, even 25% of the feeders for modular furniture, not shown on the construction documents, have to be controlled by the sensor or the time clock control for that space. There's no getting around that. And the other thing is, we'll get into it. Oh, yeah, here it is. The controlled receptacle has to be within 12 inches of the uncontrolled receptacle. I think that's in there because we did, I heard of some stories where, okay, I gotta put 2 controlled receptacles in this office. I'm gonna put them 8 feet up the wall behind the bookcase, and I will meet code. And that would have met a code in ASHRAE from a few years ago. It no longer meets code because of this within 12 inches of each uncontrolled receptacle. So what we foresee happening is more and more offices and classrooms, et cetera, will go with 4-way quad boxes. One half will be controlled and the other half. Though you can do it with one single receptacle. The top part can be controlled and the bottom can be always on. It's trying to come up with a clever and consistent way to communicate that to the people who have to live in the space.
Exactly. That's what I'm thinking about, the stickers and what happens when somebody, the refrigerator is on one. I mean, there's going to be a significant learning curve with this. And this is, I like the idea. Every once in a while, Title 24 in California kind of run amok, and some of this stuff gets off the rails a little bit. For anybody, we are at our 90-minute mark. Christopher, I want to let you completely finish your presentation. There is no point in not going ahead and getting all this information on our YouTube channel. For those of you that do need to hop off the webinar, you have met your 90-minute requirements for the 0.15 CEUs. So if you do need to hop off, no worries, but we will answer the questions at the end. So please, if you did ask questions, stay tuned for the questions, and we'll let you get back to it, Christopher.
Okay. I apologize if I've been
no hurry. Just keep going the way you're going. I want to get the information out here, so no worries.
Okay. So 50% of the receptacles have to be controlled, and it's following the same direction as the lighting controls. You can have time of day control for not more than 5,000 square feet. You can have an override for not more than 2 hours. The occupancy sensor has to shut it off within 20 minutes and signal from another controller alarm system after 20 minutes. It can be any one of those. Well, the last one that I mentioned with another controller alarm system, that only applies to receptacles, not to lighting. And exceptions, any area required for continuous operation, medical facilities, surgical rooms, of course, anything where occupant safety. So any kind of manufacturing, it doesn't have to be heavy duty. It can be light duty manufacturing assembly. If it puts anybody potentially at risk for physical injury, they're exempt. And a single modular workstation. Non-controlled receptacles are permitted to be located more than 12 inches, but not more than 72 inches from the controlled receptacles serving that workstation. So this rule, this exemption here, only applies to singular modular workstations. It does not apply to a classroom, an office like I'm in, or like in my office back in Houston. Energy monitoring required is new for 2021 for new buildings, 25,000 square feet and larger. Okay, so this does not apply to any major renovation. Chevron owns buildings in downtown Houston. If they want to renovate all 40 floors, they can do so, and they are not required for energy monitoring because it's not a new building. But they would be making all other types of renovations, and that would enforce the other rules of IECC 2021. And measurement devices must be installed to monitor energy use of the following separately. So they're saying incorporate a building management system, whether it comes from Siemens or Johnson Controls or GE, and they want to measure the energy, your HVAC, your interior lighting, your exterior lighting, and your plug loads, process loads for data centers and manufacturing, and building operations, and others like this. So there's a lot of catch-all here, but the key here is new buildings that are 25,000 square feet and larger. This is nothing new, enhanced digital lighting controls. They are essentially describing what is known as a DALI lighting control system. DALI stands for Digital Addressable Luminaire Interface. It's technology that was developed in Europe decades ago. No one owns DALI. It is a control protocol. It's digital, and it allows for all of these things. This is not a requirement. They need to have on their projects some kind of enhanced control function. Most projects, in my experience, they've been doing that with enhanced HVAC approaches, but if they choose to do it with lighting, this is the prescription for it. And there is another digital control system out there that's called DMX that could do this, but DMX would be so much more expensive than DALI that no one would ever do DMX to meet this criteria, but they would use DALI. Chevron that I mentioned is doing DALI in all of their renovations now. Functional testing of lighting. This is new for 2021. Functional testing must be done before the inspection, and you're perfectly okay to say to either be there when the commissioning agent for the lighting manufacturer is there, or have them provide the contractor when you're there making your inspection to provide evidence of testing. Okay, I tested this many sensors, this many time switch controls and daylight responsive controls, and they all work. Now, what has to be handed over to the owner, that's really not in your purview. The 90 days of the receipt of the certificate of occupancy, that's on the contractor. But you do need to say, where's the evidence of testing, and have that technician provide that information to you. So what are you looking for? Certify that the sensors are located and aimed per the manufacturer recommendations, that the sensor was tested for projects with 7 or fewer occupant sensors. Okay. When there's more than 7, so if it's a small job and there are 7 sensors on the whole job, you need to know that all 7 were tested and see evidence of that. If there's more than 7 on the job, that's the next one down here, then you need to see not less than 10% of each type of space. So if you're, what that means is if there are 40 offices that all have the same layout, 2 light fixtures, there's a sensor, there's plug load control, you need to see testing done on at least 4 of those rooms. You don't need to see a report on all 40 of those rooms because they're all identical. But in no case fewer than 1 of each combination. So if you've got a 1 lighting zone, and you got 40 offices like that, and you've got 12 offices that are 2 or 3 lighting zones, or a conference room, you would need to see the testing done on those. Those don't factor into that 40 because it's a whole different combination. And where 30% or more of tested controls fail, then you need to see all remaining identical combinations shall be tested. So if they're testing 40 classrooms and they can't show you that 4 of them passed, then you need to see the other 36 and verify that they're working accurately. And this is what you're supposed to verify. Is it timing out in 20 minutes? Is the auto occupancy control permitted to the right level? Because with vacancy sensing, somebody comes in, turns the lights on, the space becomes vacant, it turns off. That's a vacancy sensing. It can also be you walk into an office and the lights can go on to no more than 50%. And they will shut off after 20 minutes when the space becomes vacant. That too is acceptable, but you need to make sure that they're coming on to no more than 50%, not 60 or 65 or 70, and somebody's trying to skirt by. And no false tripping due to adjacent areas or HVAC. Be on the lookout if a sensor is installed right by an air vent, because you could get a false trigger, or more likely what happens is the spaces become vacant, but that air vibration from that ductwork being right there is going to keep accentuating that sensor, and it's going to keep the lights on when it shouldn't. So you do have to look at proximity of light sensor to air vents. And most of the top of the line commercial lighting manufacturers recommend that their sensors are 4 feet away from an air vent. Sometimes architecturally that's hard to get away from, but they make that their recommendation nonetheless. What you need to look out on the testing of the time switch, confirm the weekdays, you're confirming the schedule and that the override time limit is not longer than 2 hours. Testing and verification by the daylight sensor, is it calibrated? Are the lights adjusting in response to the daylight? And is the calibration equipment readily accessible? Is there a remote or is there an app for a smartphone? Okay, so we'll look at some examples real quick, and this will wind up everything. So here's your 2021 basic. You've got your switch, your ceiling sensor, your lighting control for your light fixtures, and an additional power pack for receptacle control. It's normally going to be 2 different because most light fixtures in commercial applications are 277 volt, and we, as we all know, we use 120 volt for our walls. So no one makes a power pack room controller that does multiple voltages simultaneously. But you're going to look for manual on, timeout of 20 minutes, and half the receptacles need to go off. Here's a larger open office space. Now we've got 600 square foot zones, daylight zones of 150 watts or more. So I really want to go to these 2 scenarios. So here again, 600 square feet, 600 square feet. We've got 1, 2, 3, 4 sensors, 1, 2, 3, 4 power packs, 1 daylight sensor over here, and we've got plug load control. This particular layout happens to be communicating wirelessly, but all the devices are just governing this 600 square feet and this 600 and so on and so forth. I'm loading this up to see if you, all right, so we're done, right? And if this is what you find, this would be incorrect, simply because the keypads were missing. You don't need one for each this open office space. You can do it with one, you can do it with two, you can do it with four. And there was a power pack I'd left out. But you must have a switch for all of the area. Has to be, readily accessible. You need a sensor per 600 square feet. You need a power pack for the lighting in each 600 square feet. And if you've got a daylight zone, if you've got 150 watts, you need a photocell over here. Public restrooms, it's a little bit easier. Okay, here's our line voltage switch sensor, takes care of the small bathroom, doesn't need anything else. We don't have to worry about plug load control in a bathroom. So we got a sensor, power pack, and a switch. Conference rooms, lecture rooms. You treat them just like a classroom. Maybe there's an integrated occupancy sensor. That's why I put this thing in here. So look for it this way. Okay. And again, you got power pack for lights and you got a power pack for receptacles. Okay. Public corridors. This is a good review sheet. The same things that we've talked about. You got to have occupancy sensing now, and it's got to reduce power by 50% within 20 minutes. Doesn't mean it has to go dark, but they do want the lights dimming down. And full automatic on controls with no manual control shall be permitted in corridors and all of these areas where manual operation would endanger occupant safety or security. So in that chemistry building at Texas A&M, that corridor didn't fall into this exception because it didn't create any occupant safety issues. And automatic full off is not suggested for egress illumination in interior exit stairways or exit ramps. Again, you just don't want to put anybody at risk if they have to leave a building. I kept this in here. Our friends at Crestron put this thing together as a quick guide reference. I think it's accurate. I haven't had a chance to verify myself, but you may like to print it out as a quick reference and use it yourself. And then a description of it for IECC 2021. I apologize for going a little bit long, but we do have time, Jason, for a few questions.
You could have gone another 20 minutes. I could tell too. You were trying to kind of hurry there at the end. I knew I should have booked you for 2 hours. You know too much.
And actually, I'm here at someone else's office in College Station because I have another presentation to give in 15 minutes.
Well, if you need to hop off now, you.
I do not, because I'm all set for that, and I just have to walk down the hallway. So, but if there are some questions I can help with for the next few minutes, I'd be happy to do it.
Okay, great. What's the recommended distance in between sensors and corridors?
It's actually based upon the sensor that's on the ceiling. And I have to, I'm not trying to equivocate. Most of the sensors on the market that are used in corridors are going to be 1,000 or 2,000 square foot, usually dual tech sensors. Dual tech sensor is something that's listening, ultrasonic or microphonic, and PIR, passive infrared sensing. But corridors, these things are going out in circles, right? And corridors are long rectangles. So you would need several of them, because again, if you're 10 to 12 feet high, you might get 10 to 15 feet of coverage
Oh, wow.
each side. Whereas there's a company out there called Steinel. They make sensors specifically for corridors, and they can go 70 feet in one direction. So depending upon the manufacturer.
Product specific, very much.
Yeah.
So. Yeah.
Yeah.
Okay. Would integration into a building automation system serve as a code approved time clock?
Yes. But and I say that simply because the lighting control manufacturers that I know of, in order to integrate with the building management system, they've got to put in a central processor. And that central processor is going to have its own time clock functionality. So usually what happens on projects where they are wanting to have the building management system run the time, the manufacturer technician that's setting up the lighting controls sets up the lighting controls as a backup in case BMS fails or goes down for whatever reason. But all the primary players, in order to integrate with a building management system, they have some sort of energy manager, central processor that's got the time clock control built into it. And then, because it's a whole different ballgame, you have to network all the lighting controls to a point that can then grant access and allow the building management system to communicate to the processor that then will see all the sensors on the network. Because this is looking at it another way, Siemens and Johnson Controls, et cetera, they don't have a way of making direct building management system connection to a ceiling sensor. There needs to be some intermediary, and that's that manufacturer's processor.
Okay. And then I've got two more real quick. I had 7 of my own, but we quite clearly aren't going to have time for mine. So I just want to get to the 2 that the folks asked. Is energy monitoring required for warehouses?
If it is a new building that's greater than 25,000 square feet, the answer is yes.
Yes. And then last question, why do we have receptacle control from energy saving point of view?
That's an excellent question. And what I know about that coming from California is their price per kilowatt hour is a lot higher than it is here in the state of Texas. It makes less sense. That's my personal opinion. But they did find that there was enough savings on devices that don't need to be on all the time, that are always plugged in. When they're always plugged in, even if they're turned off, there is a small semblance of power that's going from that relay, that switch leg, that breaker box to that device. And if they can interrupt that 50% of the time over the vast majority of commercial buildings, they can find significant energy savings. California uses a heck of a lot of power. If you want a quick reference, because I used to work in the entertainment industry, before they closed more studios, this is only going back like 15 to 25 years, when there were more studios in Hollywood that were in full production mode, and they do it seasonally, just like a lot of places. Mm-hmm. They would draw so much power, they could actually take almost the entire city's power allotment just for the studios. So they had to come up with a way of managing that. And needless to say, a lot of studios started going remote, and they also went to a lot of generation, a lot of lights being powered off of generators. There's just a heck of a lot in California. And so they came up with the idea and they found, yeah, this works. And we are saving, I can't tell you what the percentage is, but it does cut down on the energy draw.
Yeah. Well, then now we're implementing all this wind and solar and shutting down coal plants, which crypto mining companies come in and buy later and just stack full of servers and run the entire power plant to do nothing but mine crypto. But that's, we won't get on that side. No, that's kind of crazy what's happening on that end. Christopher, I cannot thank you enough. Fantastic information as always. And folks, just remember, you will get a PDF of the presentation today. Jessica asked to go back to a slide, but you'll have a PDF of the slides, Jessica, and then a copy of this will be on our YouTube channel this afternoon. I know there's a lot of complicated stuff there, and I guarantee you there are a few architects and engineers that know this stuff like Christopher does. I would imagine your general impression on how thorough architect and engineers' knowledge of this is when they're designing lighting for spaces?
It really is a mixed bag in the Houston market. Because that example I gave you of the daylight sensors that I pulled out, that wasn't from a project from 4 or 5 years ago. That was a project from last year. So many of them prefer to err on the side of caution and put in more daylight sensing than is needed, simply because they haven't fully spent the time to embrace what's required. I saw in the chat room somebody wanted to look at this sample private office real quick, so I jumped back to that really fast. There wasn't anything else said after that, but I just wanted to revisit that again. So a switch on the wall, the assumption it's vacancy sensing. You got to have a switch anyway. You got to have the off button.
But most of the time on that one though, isn't that going to have under 150 watts? Aren't you going to meet your exemptions on an office that size most of the time?
But you still need 150 watts is for the daylight sensing. That's right. If you have one light fixture and it's less than 100 watts, or you're at 0.6, you can get exempt on a sensor. But honestly, most of the engineers aren't going to know and realize that. So you're going to see simple offices laid out exactly like this. And this room, this can be a network or a standalone. Network is done simply for building management system integration or overall time clock control. We want to shut the whole building off at 10 p.m. every night. That would be the only reason to network. Otherwise, you can meet code without networking every day of the week.
Gotcha. Well, you have all of 5 minutes to get to your next meeting. So if you need to take a little break real quick, you better get to walking. Yeah. Thanks again so much, Christopher.
My pleasure. Thank you all very much. And again, I think the work that the inspectors are doing for the state of Texas and your leadership and guidance is a wonderful thing. The need for power in our state population is going to continue to grow. So these are not small things. These are not small items. And it's hard to see because it's on such a large scale, but it does benefit all of us ultimately. So thank you all for your work.
Fantastic. Thanks again. Thanks for joining us, everybody. Everybody have a great afternoon. Bye.
You too. Bye.